Hello, my name is Samir, and today I'll show you my final project for my 389A class. For this class, I trained an LSTM to complete sentences in Shakespeare English. It was really interesting, a really interesting project. I got my Shakespeare text online from a website called gunsburg.com. You can download the entire Shakespeare collection there. It consists of plays and sonnets. And the first thing I did was I just reran the whole model. I created the whole model and I ran it on the whole data, and I really didn't get the output as I expected. Then I looked at the data again and found out that I had two different varieties of data. The first one was a play. As you can see, there are like characters in here. There's uh, plot changes, transition lines, scene one, a street. You have things like these, which are acting roles. It is a script as such. You don't really have a continuation, things are repeating, a pattern which like a machine can learn, except for maybe at these points, which I was counting on it to understand, but then I looked at sonnets, which were like, on the other hand, much simpler. You have 14 lines of repeating text, of like similar text, not repeating but similar text, which kind of follows a pattern of 14 lines which have like the same uh I want to say rhythm. We used from, yeah, I mean like something like that. So this is what I was trying to train my model on, and it's really interesting. I got all these other things. I imported all my files. I imported my project, the sonnets. I stored all the sonnets in one folder, and I have a plays on another one. The plays I might try training it again sometime later, but for now let's just stick to sonnets. And here are all the sonnets I have, and I take all the sonnets and I concat them into one huge string. As you can see here, I concat them all to one huge string. And now to do this, we need to first convert the string to numbers, because the machine understands numbers better than strings. So the first thing I do here is I find out all the unique characters in the poem. So here is, I take a sorted list of set of all poems, and it gives me all the unique characters. And then what I do is I take all the unique characters and I assign them one number, and their number will be unique because they are unique. And I take one which is from numbers to characters and characters to numbers. Here it is characters to numbers. As you can see, you have A B C D. I keep everything in lower because it just gets rid of redundancy, which I don't want. And here it's kind of interesting. I left out next tab and the next line characters. I left them in there. I was thinking about I should probably concat them because they were coming in the poem, and I was confused about it for the longest time. But I decided to leave them in there. I was really surprised to see that the machine started understanding them as well, and it knew when to like return a next line character after the end of line, which is kind of interesting because it would like read a whole line. As you can see in poets, there are not that much punctuations in the end, but there are a few. As you can see, there's one right here, there's one right here, there's three right here, there's one right here. But like, if you look at here, you need to understand that you need to move to the next line, which I was surprised it was able to understand from these two characters. And now the next step would be data pre-processing, in which what I do is I have the whole string of data. I have the whole string of data, and what I do is I take the first 20 characters, and that is the X string, and I take the 21st character which comes after that, and that is going to be the label for the 20 characters in a row. So, given the 21st characters, as you can see, the sequence of the first 20 characters, is the machine able to predict the 21st character? And what it's gonna do is it has again the same options out of these 38 characters, and it needs to pick one. What I do right here is I take the np util2 and make a categorical hot encoding for my white rains. this was a this was like rather much easier to do. Um, yeah, and then I have the model, which I have the LSTM model, which I have an LST model which takes the inputs, and I have three LSTMs which are split between each other by a dropout, which drops out the lowest values in them. It really helps get rid of. It only takes the best values and moves them forward. These are really good. As you can see, now we have the actual LSTM, and you have all of them are set to trainable because I do need to trim all of them. And then I have a dense layer in the end, which just gives me a Y output, which is the categorical analysis, which is the categorical which category of the 38 it needs to output. What is the 21st character in the array? And I have softmax for that and categorical cross entropy for the loss. Um, I trained this model on AWS. If you guys want to look at the AWS, uh, it took a really long time to train it on AWS. As you can see, I actually did it on 18 epochs and set the batch time to 20. It took around, I want to say 2 hours, 30 minutes for one epoch because of like the huge sum of like data I had. As you can see, I had like a lot of data. And so it took like 2 hours 30 minutes, and I trained it on AWS because I can't train this on my computer, and it took around 48 hours for it to train 18 epochs. I wanted to ideally do like 100, but like that was a lot to do in like the time span. But 18 still ended up really well. And here I load the weights. The weights are available on GitHub if someone wants to try them out. And I have this method which generates a text. Given any input text I give it, it it goes around and generates 200 next characters and and prints them out and returns an output. And here it is. Look in the glass and tell the and I generate this. I first convert this lower because it's not able to find L's and stuff like that. But this is really interesting. Look in the glass and tell the shame of her that she stars all the world and she doth be gold. Um, I mean, I'm not a judge on Shakespeare, but I feel like it did a really good job at this. Um, there are a few things which are just like pointing out, like it does repeat a lot of words right here, which I'm not. Yeah, it's like it's repeating a lot of words, but it's all about the training. I think if I would have trained it at much more epochs, it would like give us a much better data. Um, then I tried another Shakespeare quote right here. Like Shakespeare, this is all from his sonnets. I just take a line and like it tells me it like predicts further on it. Um, yeah, it's rather very interesting. It uh, this is the one I had. The next one, then let now winter's rage hand defaced. Weary they have seen the skies, and she had not to be see there. Yep, rather pretty good. And then just for fun, I put in modern English characters to see what's gonna happen there, and surprisingly, well, not surprisingly, but like it did not do well at all as expected. In both of them, it went in the same loop. Um, another thing I could have, another reason I have is the last word in all of them starts with an S, and it's like the same spider smear. Like that's yeah. So like if you see like it's kind of like the last ears. Um, I had a feeling that that's probably why it's like messing it up. Um, I could try doing this, but let's see. Um, hmm. Oh, my model is not trained. But like that's it, guys. Um, yeah. Oh, it's smaller. Let's try this one. Yeah, it takes a while, but the beauty of this project is you can actually take any kind of data set. You can change, ideally, you can actually change this data set to anything you want. You could give it books, novels, you can give it tweets for like from one specific person. And with time, with like the more training you provided, it would be able to learn patterns and recognize what kind of way the person is talking to and like recreate that again, which is the beauty of this, which is really really interesting. I might train this model again on other things after this. The only drawback to this whole thing, the whole project, is the training time. For it to like actually give you good results, like good contradictory results, you need to train it to 100 epochs minimum. But the thing about 100 epochs is, if you do it on a regular GPU, it's gonna take a really long time, which might not be worth it. And this is, yes, um, it still ends up repeating, but it does much better than the last one. So I feel like it might be what I had predicted. The sounds, it is messing up with some sounds in the end, because like it's all about the word choice in the end, and it might be messing those words up, which it's not able to find a rhyming word for the next to like keep the rhyme going on. But well, that's all. Hope you enjoyed this.